everyone, let's take a look at this example of a lottery winnings decision, and it illustrates some present value analysis. Would you rather get $400,000 now, or instead get $1 million, or approximately $1 million, distributed to you in monthly amounts of $6,000 over the next 16 years? Assume that you would earn 8% on the $400,000 if you took the money now, and you would earn 8% on any funds you would invest on the $6,000 monthly payments that you would receive if you elected to go with the monthly payments. Okay, first let's drop in the variables, the interest rate. Okay, I'm going to hit the F2 key, and what you see is it's 8% divided by 12 because we need to define this in terms of the periodic interest rate. In this case, it's a monthly problem. So take the 8% divided by 12 to come up with the periodic interest rate. Okay, the payments are $6,000 given in the problem, and the number of periods, again, I'll hit the F2 key, is 16 years times 12 periods per year, right? One for each month. So you're going to receive payments of 192. Okay, now let's solve the present value. I'm going to type in equal PV, hit the left paren, and I'm going to move up to the formula bar, which you can see right at the top of the screen, so that it pulls up a function argument, and now we can fill those in. And let me move this over, and you can see Excel will tell you a little bit about what each parameter needs to be. Okay, so let me slide this over. The rate is given right there. It has to be the periodic rate. The number of periods is given right there. The payment amount is given right here, but I'm going to multiply that, or actually make that a negative, so that our answer will come out as a positive. Keep in mind that Excel always interprets this in terms of inflows or outflows. So if you give the payments as a positive number, it assumes you're paying it back as an outflow. So we'll assume that these would be payments you're giving up, so we can see the present value, or the answer, in terms of a positive number. There's no future value. We can skip that, and it's a normal annuity, so we can skip that too. So once we have that, I can hit the OK button right there, and we have a present value of $648,701. Let me hit the F2, and you can see there's the variables you need. Okay, the lump sum amount said you get $400,000 now, so we just need to compare the two and give it the higher value. And just to show one other function, I'll use the max function of Excel. I'll hit the F2 again. The max function says give us the various parameters to consider, and every time you add one, it will give you another one, but we only have two. Now, you really don't need to do this. You could do this in your head, right? But it tells you that the present value of the 648 is the better option. So your decision would be take the stream of payments, and now that you might want to consider your longevity in this. If you were an 80-year-old person, the lump sum amount probably would be of more value to you. And we don't know, though, in this problem, whether if you die, whether the remainder would go on to your estate, which could be a consideration for your heirs after you die. Okay, everyone, that's just a quick example of how I would use the present value function in Excel to determine whether we should take a lump sum amount now or elect to go with the stream of payments. And I hope you found this demo beneficial.